Why does eating the same meal at midnight do something completely different to the body than eating it at noon? The body runs on a 24-hour internal clock. That clock controls hormones, digestion, blood sugar, and metabolism. When food arrives on schedule, everything works together. When it arrives late after the body has already shifted into rest mode, the response is different, and that difference is not small. Understanding what actually happens inside the body during late eating reveals something important about timing and why when food is eaten may matter just as much as what is eaten. So what exactly is the body doing at night that makes late eating a problem? The human body follows a circadian rhythm, a 24-hour biological cycle that regulates nearly every system in the body. This is not just a sleep schedule, it is a full operating system. During the day, digestion is active. Insulin works efficiently. The body expects food and is ready to process it. At night, that system begins to shift. The body starts preparing for sleep, not for incoming fuel. Digestion slows. Hormone levels change. The internal signals that help the body handle food begin to drop. In simple terms, the body is built around a schedule, and that schedule includes a window for eating and a window for rest. This rhythm is driven by a cluster of neurons deep in the brain called the suprachiasmatic nucleus. This internal pacemaker reads light signals and coordinates timing across every major organ. The liver, the stomach, the pancreas, each runs its own local clock, synchronized to that central signal, and all of them share the same expectation. Food comes during the day. When food arrives outside that window, the body still processes it, but it does not process it the same way. What is one of the first systems the body struggles with when food arrives late? After eating, glucose enters the bloodstream. Insulin is released by the pancreas to move that glucose into cells, where it can be used for energy. During the day, this system runs smoothly. Insulin is highly effective, and blood sugar returns to normal quickly. But at night, insulin sensitivity drops. The same amount of food that would cause a mild blood sugar rise in the afternoon can cause a higher and longer-lasting spike at night. The cells become less responsive to insulin, so glucose stays in the bloodstream longer than it should. This is not a flaw, it is a built-in feature. The body is saving energy for rest. It is not expecting to process a large glucose load at midnight. The liver compounds this problem. During the day, it clears excess glucose from the blood and stores it as glycogen. At night, that activity slows. So not only is insulin less effective, the liver's backup clearing function is also reduced. Glucose has fewer places to go, and it lingers. When this happens repeatedly, it does not stay isolated. The body begins adapting its entire blood sugar regulation around this late-night pattern. But blood sugar is only part of the story. There is another hormone involved, one most people would never connect to eating. As night approaches, the brain releases melatonin. Most people know melatonin as the sleep hormone, but melatonin also plays a direct role in how the body handles glucose. As melatonin levels rise, insulin's effectiveness falls. Research has shown that melatonin receptors exist in the pancreas, and when melatonin binds to them, insulin secretion decreases. This is one of the reasons why nighttime blood sugar responses tend to be more pronounced. The body is receiving two conflicting signals at the same time. One signal is telling the body to prepare for rest. The other signal, triggered by late eating, is asking it to process food. This may help explain why shift workers, people who regularly eat at misaligned hours, show higher rates of metabolic issues over time. The body manages short-term conflict, but when the misalignment is nightly, the chronic load on glucose regulation begins to show. When signals are misaligned, efficiency drops. And it is not just blood sugar that pays the price. So what happens to sleep when the body is asked to digest food at the same time it is trying to rest? Digestion is not a passive process. It requires energy, blood flow, muscular movement in the digestive tract, and coordination between multiple organs. When food is eaten late, all of that activity continues while the body is trying to shift into recovery mode. This can make it harder to fall asleep, and even when sleep happens, it tends to be lighter and less restorative. Studies have found that late eating is associated with reduced time in deep sleep, the stages that are most critical for physical recovery, memory, and hormonal regulation. In simple terms, the body is resting, but it is not fully recovering. The digestive system is still running, and that quiet interference adds up night after night. There is also a thermal factor. Core body temperature naturally drops as part of sleep onset. That cooling signal helps the brain transition into deeper stages. But digestion generates heat, working against that drop. The result is a real delay in reaching the most restorative phases of sleep. Poorer sleep affects energy levels the next day, and reduced energy affects behavior, including eating behavior. Here is where it becomes a cycle. Late eating does not just affect the night it happens, it reaches into the next day. Hunger is regulated largely by two hormones, leptin, which signals fullness, and ghrelin, which triggers hunger. Sleep has a powerful effect on both of these hormones. When sleep is shortened or disrupted, leptin decreases and ghrelin increases. The result is stronger hunger and reduced satisfaction the following day. Late eating disrupts sleep. Disrupted sleep changes hunger hormones. Changed hunger hormones increase appetite the next day, often leading to more eating, more late eating, and the cycle continues. The body is not making mistakes, it is adapting. And what it is adapting to is a pattern that keeps repeating. What makes this loop difficult to break is that ghrelin-driven cravings tend to pull toward high-calorie, high-carbohydrate foods. The hunger from disrupted sleep is not asking for a balanced meal, it is pushing toward fast energy, the exact type of food most likely to cause another blood sugar spike late that evening. This is the key insight. The body does not respond to one late meal. It responds to patterns, and when late eating becomes a nightly pattern, the body rebuilds its baseline around it. Here is the larger picture. For a long time, nutrition science focused almost entirely on calories and nutrients. What was eaten? How much was eaten? The idea that when food is eaten could be just as biologically significant has only gained serious scientific attention in recent decades. Research in the field of chrononutrition, the study of how eating timing interacts with the body's circadian biology, has found that meals eaten earlier in the day tend to be handled more efficiently across nearly every measurable system. Blood sugar control is better, fat storage is lower, sleep quality is higher, and long-term metabolic health outcomes appear more favorable. This does not mean a single late meal causes lasting damage. The body is remarkably adaptable. What it does mean is that the timing of eating is a real biological variable, one that the body uses to organize its systems. When timing is consistently out of sync with the circadian clock, those systems are consistently working at a disadvantage. In evolutionary terms, this makes sense. For most of human history, food was not available at night. The body evolved around a rhythm of eating during daylight and resting in darkness. Late-night eating is largely a modern pattern, and the body has not fully adapted to it. So what actually happens to the body when food is eaten late at night? The internal clock shifts into rest mode. Insulin becomes less effective. Melatonin interferes with glucose processing. Blood sugar rises higher and stays elevated longer. Digestion slows while the body is trying to recover. Sleep becomes lighter, and the next morning, hunger is stronger. None of this is dramatic from a single meal. But when late eating becomes a nightly pattern, these systems do not just react, they adapt. The body reorganizes itself around the timing it is given. That is what makes timing matter. Not because the food changes, but because the body receiving it does. And over time, the body does not just respond to that timing, it reorganizes around it.